Hello everyone. In this video we are going to study about number system, that is from NCERT Mathematics class 9th. Let's start the work. See, first of all, this is a number line. In our previous classes we have studied about this. So if I start using 0, so as we move to the right side we get 1 2 3 4 5 and so on, means number which are positive. And when we move to the left side of this number line we get number which have a negative sign, -1, -2, -3, -4 and so on. So we know that the number line is unending on both the side. These arrows are showing this, that this is unending. We don't know the highest number and the lowest one, because negative number line is also unending. Moving to the next, see this natural numbers. So the numbers which are used for counting, they are called natural numbers, or they are also called counting numbers. Suppose we have collected all these numbers from 1 to 1 to 3 and so on, means they are unending. So suppose we have collected many numbers in a box. Their numbers start from 1 to 3. So the collection or the box will be named as natural numbers box and denoted by N. Next, now we have a box with a number 1 to 3 in that, and the denotation was N. They were natural numbers. Suppose the 0 will also enter in this, we put a 0 also there. So the new collection or the box will be named as W, which means whole numbers. If 0 is included in these natural numbers, they will become as whole numbers. So it is very simple. When we have collected 1 2 3 and so on in a box, the box was of natural numbers, but when we have added 0 to it, it becomes the collection of whole numbers. Moving to the next one. Now see, on a number line we have 1 2 3 and so on, we have a 0. Now there are some negative numbers, there are some negative numbers also. So in that particular box in which we have already whole numbers, means all these numbers, suppose these negative numbers will also be added to this box. Now this box will be called as the set of or the container of integers, and it is denoted by Z, not I as we were using the initials, but in this case it is Z. The set of integers or all the integers numbers together are denoted by Z. Z means we are using a word Zehlen. This is a German word. This is a German word which means to count. So for integers we are using Z, and integers contain, see what they contains. Integers has negative numbers, positive numbers along with 0. All together they are called integers. But if we remove negative numbers, they will be called as whole numbers, and if we remove 0 from them, they will be called as natural numbers. It's very simple. Again I am repeating this for you. If we take these numbers, they will be called as natural numbers. If we add 0 in them, or we add in the collection, that collection will become the collection of whole numbers. And if we add these numbers too, they will be called as integers. So there are two types of integers. These are negative integers and these are positive integers with a positive sign which is hidden, and these are negative integers. Along with 0, negative integers, positive integers and 0 make a set of integers. These all are called integers and denoted by Z. Moving to the next one. Now Except integers, natural, whole numbers, there are some numbers which are called rational numbers. The numbers which can be written in the form of p upon q are called rational numbers because it is a form of ratio. See, this is a ratio of something. So the name is given rational numbers because of this ratio. So there are many rational numbers we are gone through: 1 upon 2, 3 upon 4, 7 upon 9. These all are rational numbers because they all are written in the form of ratio. There are two cases possible in this rational numbers form. Suppose we have taken 7 upon 8. So when we solve this using this division method, what we will get? We will get 0.8 0.8875. So we can see this is a decimal expansion of a rational number. So rational number can be written as decimal expansion, and this decimal expansion is terminating, means decimal after 3 decimal it was terminated. Let me show you the complete division. Okay, this is a blank page. Now I'll show you. See, we have divided 7 by 8, so we use a decimal for writing a 0 here. So 8 eights are 64, and when we subtract, 6 is left. We have a decimal, so we can put a 0 here again, and 8 sevens are 56. When we subtract, we will get 4, and we have a decimal, so we can put a 0 here. Divide this by 8. 8 fives are 40. That means, you see now, because in the last we get nothing, that this is a 0, so we can say that this is a terminating decimal expansion. So see, yes, this is yani 8 7 upon 8 is a terminating decimal expansion. Terminating decimal expansion. This is first case we have done. Now see the second case. See the second one. Suppose we have taken this 3 upon 10 upon 3. Now using division method, 3 3s are 9, and when we subtract we get 1. Put a decimal, we can write 0 here. 3 3s are 9 again, and as we move further, 1 will be left. Again 3 3s are 9. So when we divide this by 3, 3 3s are 9, and this is unending, means 3 will come on and on. So what we have concluded that this is a non-terminating, because the answer is, because the remainder is never 0, so this is a non-terminating. And the second thing is, these units are repeating themselves. 3 3 3 are coming after one another, so this is non-terminating plus recurring means repeating. So in this, the second case says that decimal expansion can be non-terminating and recurring. Moving to the previous page. See, rationals. Again we are on rationals. So you have seen that, first let me erase this. Now you have seen that rational numbers are of two types. The first one was terminating, in which the decimal comes 0 after dividing, after dividing 2 3 places. The expansion was terminated. But second case, that was non-terminating plus recurring. The term was repeated, non-terminating plus recurring. So there are two types of rational numbers. One is terminating and second one is non-terminating recurring. So if these are rational numbers, so what are irrational numbers? This I'll tell you afterwards. First, see irrational numbers. Suppose there are some numbers which are non-terminating, plus they are non-recurring also. They are non-recurring. So they will be called as irrational numbers. Means after division their term is not repeating in decimal expansion. Those numbers cannot be written in the form of ratios. So they are called irrational numbers. Moving towards this chart, just see, first of all I have told you about natural numbers. They were 1 to 3. When we had added a 0 to them, they become the set of whole numbers. See, whole numbers and natural numbers has only one difference, that is of 0. Now see integers, they all are integers, whole numbers, natural numbers, and along with negative numbers, together they are called as integers. And if we talk about rationals, so all these are called rationals, because natural numbers can also be written in the form of ratio. Suppose 1 is written, so I can write this 1 upon 1, 2 can be written as 2 upon 1, 3 can be written as 3 upon 1, okay, minus 4 can be written as minus 4 upon 1. So these all are rationals because they can be written as in the form of ratios. And about irrationals, there is a wide topic. We will talk about irrationals in our next video. So you can learn this chart and this will help you to understand natural, wholes, integers and rationals. One thing is left which I'll show you, that rationals can be written in the form of decimal expansion and decimal expansion can be written in the form of rationals. See, how can we show this, that decimal expansion can be written in the form of rationals? Suppose this is a decimal expansion, 333 and so on. So this can be written in the form of a bar, 3.33 this. You will get this form also in some books. In many books you will get this. So first what we are going to do is, let's start again. See, first of all let x equals to 3.333 and so on. Now multiply both the side by 10, we get 10x equals to 33.333 and so on. This can be written as 30 plus 3.333 and so on. Now see, where from we started, x equals to this much, and this can be replaced by x. You can see this, x equals to 3.33, so this term can be replaced by x. So I am writing 10x equals to 30 plus x. Now moving to the next step, I'll show you the next step. See, 10x equals to 30 plus x. So when we solve it further, this is 10, the x will be subtracted from this 10 and becomes 9x equals to 30 upon x, and when we solve this we get 30 upon 9, divide 3 tens are 30 and 3 threes are 9, we get a rational. So decimal expansion can be written as rational and rationals can be written as decimal expansion. So the term which are terminating, the decimal expansion which are terminating and which are non-terminating recurring can be written as rational, so they are called rational numbers. But in some cases the term is neither terminating nor recurring, okay, in that case the expansion is said to be irrationals. About irrational I will make a separate video for that. You can watch it and get the topic. Till then, have a nice day and study hard. Thank you.